Okay, grade 10s. It's grade 10 today, this morning, good morning. My network just about came back. Nice. I hope you guys are good. I hope everybody's well. I hope you guys are popping on this beautiful Monday morning, one day before school resumes. One day before school resumes. We are doing grade 10, guys. Grade 10. This is grade 10. Grade 10. All right, and we are picking up from where we left off. I think it was 2 days ago, actually. 2 days ago. Grade 10, and we're doing Euclid. Grade 10 Euclidean. Right? And just for those who might be wondering what exactly we'll be covering in this grade 10 Euclid session, we have basically started off with Euclidean Geometry sessions for grade 10, and what we have been doing to begin, we were able to revise the basic results that were established in earlier grades. We established the basic results that we established in earlier grades for lines, angles, and triangles. All right, we have you guys can actually go to my, I think what's important here is go to my YouTube channel. The sessions that we did were quite interactive. They were not me just teaching, you know. I had a few grade 10s come on as guests so that they could actually like go through with me the work that we are doing. So this will be not any different. So we are still on the first part, sort of like we are still covering the first part of Euclidean geometry, and what we are trying to do is we're trying to establish those earlier concepts that we did in grade 8 and 9. The thing is, it says so in the actual document that teachers use to teach grade 10s, that the first thing that they need to do before they jump into what they have to cover for this year as for grade 10, they have to first revise those earlier theorems for lines, angles, and triangles. All right, and so far we haven't done congruency and similarity. Hopefully today we'll get to that. So we are just going to do the corrections for this work. I gave the grade 10s that were here 2 days ago 15 good problems, right? And all of them are grade 8 and 9 type problems. Yeah, so we wanted to ensure that we are able to use the acceptable reasons that are covered in the document that I had shown to the grade 10s last time. Because when we write our reasons, we need to make sure that they align with the acceptable reasons that we are supposed to use whenever we are solving a geometric Euclidean geometry question. Okay. Just give me a sec. I'm sorry. Just wanna. All right, I'm back. So let's go. Let's jump right into it. Okay. So if we look at this diagram, we've got PQR, we've got M, we've got line PQ, line RQ. They meet. They are joined there, and then we have X and 2X, and then we have this box here, which we know this box stands for perpendicular, and perpendicular means the angle there is 90 degrees. So we needed to find the value of X giving reasons. All right, so let's go. How do we go about finding the value of X giving reasons? So we can see, guys, that this X here and that X there, they are angles that basically, if added together, they give us 90 degrees. Okay, yeah, so hopefully we can see that. All right, and that's very important to note. So we know from this statement that PQ is perpendicular. PQ is perpendicular to RQ. And I mean that is given to us. We can see that. All right. PQ is perpendicular to RQ. Furthermore, we know that X plus 2X is equal to 90 degrees. Why do we say X plus 2X is equal to 90 degrees? Because this box, which is perpendicular, means 90 degrees. What's the reason? We say comp angles. And maybe you're asking, what does comp angles mean? Remember, angles that add up to 90 degrees are called complementary angles. All right, then x plus 2x gives us 3x. And then guys, when we solve for x, of course, the coefficient of 3, we divide both sides by the coefficient, which is 3, because the relationship between the 3 and the x is multiply. We get a beautiful sweet answer of what? Of 30 degrees. And that is as simple as we are able to find and solve the value of x in this particular diagram. So it's very important to know, all right, yeah, what we have in our sketch, what is given to us. We are given this x here, and then we are given the 2x there. These two angles together, they add up to 90. How do I know that? It's because this line PQ is perpendicular to RQ. All right, so this is very key. PQ is perpendicular to RQ. That's given to me. X plus 2x is equal to 90 degrees. My reason is complementary angles. And then obviously my simplification, my solving for x and getting x is equal to 30 degrees. Okay, next step, next one, number 2. We've got line PQR. We've got 2x. Please take note, guys. 2x is from here to there. 4x is from this line QS to here. 3x is from this line QT all the way back to the line. All right. And these angles, 1, 2, 3 of them, what do we know about them? These 3 angles, what do we know about them? What can we say? What is something we can state? Flower girl, very nice. Those angles, they add up to 180 degrees. Why do we say they add up to 180 degrees? What is the foundation of us saying they add up to 180 degrees? What is the basis of us saying that? Okay, add up to 180 degrees is the same thing as supplementary. Flower girl, very true. Angles on a straight line. So what we then do is we say 2x plus 3x plus 4x is equal to 180 degrees. What is the reason? The reason is angles on a dot line. All right, and this is in line with what we had said about that document that we use of acceptable reasons. The symbol for angles on a, and then STR, meaning straight for short for straight, and then dot line. Angles on a straight line. Then we solve 2x plus 3x plus 4x. I'm sure you guys know what we do when we're adding like terms. We keep the variable, we add the coefficient. 2 plus 3 plus 4, that gives us 9x is equal to 180. We divide both sides by 9. We get a beautiful answer of x is equal to 20 degrees. Okay. Statement, reasons spot on according to the acceptable reasons. Of course, equating, simplifying, and then solving for the value of x. X is equal to 20 degrees. Okay. Chop, 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 chop. Number 3, we have line AOB. Okay, so once again, line AOB, we have angles x plus 30 degrees, which is there to here, from the straight line to this particular line OD. From that line OD to OC is 70 degrees. And then from the line OC back to the straight line. These 3 angles added up together, we say are angles on a straight line. They are next to each other on a straight line. They complete a straight line. Therefore, we say that these angles, they are supplementary because they are lying on a straight line, and they are adjacent, meaning they are next to each other. So what then can we say? I'm sure you guys are seeing this with me. X plus 10, which is the binomial, plus 70 degrees plus x plus 30 degrees, that gives me 180 degrees. And then my reason, angles on a straight line, okay, for short, as the acceptable reason says. Then like terms we add. X plus x, we know that's 2x. 10 plus 70 is 80 plus 30 is 100 and 80 plus 30, 110. We transpose the 110, isolate the 2x, transpose the 110. 110 crosses over as a separate term. Its positive changes to negative. We get 70 degrees. 2x is equal to 70. And then, of course, when we divide both sides by 2, I'm sure you guys know the answer is x is equal to 35 degrees. Please excuse me for the noise. There are occasionally trucks and buses that pass through, actually trucks more specifically, that pass through in my neighborhood, and I'm really sorry about that. Okay, nice. All right, sounds good so far. Hopefully we are going nicely. You can see that the grade 8 and 9 geometry, of course the grade 8 and 9 geometry needs to be fine for us as grade 10s in order for us to be clear with the grade 10 geometry. Our grade 9 and grade 8 need to be sorted. This is grade 10 and we are revising the basic results that were established in grade 8 and 9, because it's important for us as grade 10 learners to know those basic results and know how to apply those results. Okay, yes, Tebucho, we do, but you see the thing is I just decided to do it mentally. All right, yeah, we divide by 2, definitely. That's what I did. If you divide this by 2x by 2, you get x. You divide the 70 by 2, you get 35. So I just decided to basically write the result of the division by the 2. Okay, which is typically what you guys see when you are looking at a memo. If you are looking at a memo, they don't usually show you the step of dividing by 2, because that is something that, of course, because you've divided by 2, this is the answer. You know what I mean? Otherwise, of course, we as learners, we do what we have to do. Okay, let's look at this one. Here in this particular diagram, we can see this angle here. All right, 90 degrees this angle. Okay, yeah, remember the box stands for perpendicular, and perpendicular means angles equal to 90. So that's 90. So we have this angle here, that angle there, that angle there, back to that angle there. I'm sure you can see, guys, that this is a point. All right, and these angles around this point, what do we know about them? What is the relationship that exists between these angles? Okay, very good. Angles around a point, flanges men, definitely they add up to 360 degrees. Okay, yeah, they all add up to 360 degrees. So that's the thing about these angles, right? Someone else could have probably looked at this and been like, okay, what about, sir, this angle being vertically opposite to this angle? I want to ask you guys, can we say that this angle 90 is vertically opposite to 4x? I'm asking, can we say that? Can we say 90 degrees is vertically opposite to 4x? Can we say that? You see, with the people that vouch for that, guys, right? This is the lesson I definitely want to teach you then. Please, guys, remember vertically opposite angles, okay? It's when two straight lines intersect. If two straight lines are intersecting, this line is straight, this one is straight, then we can say these angles are vertically opposite angles. Okay, this one here, you can see, guys, AC, and look at this, D, 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 is this straight? No. So we can't say this 90 is vertically opposite to 4x. And this is something I will need you guys to be aware of, because in the previous live that I did with the grade 10s, some people were making the error of thinking vertically opposite angles, as long as it is opposite, it's vertically opposite. No. And remember, vertically opposite angles are equal. So we can't say 90 degrees is equal to 4x. We can't. No, no, no. All right? Unless the two lines intersecting are straight, then we can say they are vertically opposite angles. So always check if whether the two lines are straight as they intersect. Are you with me? Okay, so let's go. That's why in this particular question, we can only utilize, in this particular diagram, we can only utilize angles around a point. We cannot utilize vertically opposite angles. If we do that, hey, we are going to have problems. So we need to use revolution. We have no choice. Okay. So I hope my people, you are hearing me very well, because if you are hearing me very well, then you will not fall into the trap. All right, you won't fall into the trap. So revolution is the only way. And what's nice is that revolution can be used, angles around a point can be used. Why? Because all angles around this particular point are actually appearing. We have 3x plus 40, it's there. We have 90, it's there. We have 3x plus 30, it is there. We have 4x, it is there. If you check this out from here, let's say our starting point is here. Angle covered. From here to there, angle covered. From here to there, angle covered. From here to there, angle covered. From here back to where I started, angle covered. I can add all these angles and say equal to 360. Reason, angles around a point or angles in a rev. So when you answer it, x plus 30 degrees plus 90 plus 3x plus 40 plus 4x is equal to 360 degrees. You see? Are you with me? Reason, we write that reason that is appropriate. Please guys, excuse me for, this was obviously my numbering for the other problem. Okay, so let me just do this. Let me have another working paper. I think that will help me a lot. Okay, just for working out. So x plus 30 degrees, we had said, plus 90 degrees plus 3x plus 40 degrees plus 4x. All these angles add up to 360 degrees. Are you with me? All right. Then our reason, angles around a PT, a point. This is according to the acceptable reason document that I had shown you. Or someone else could say angle in a rev. Angles in a rev. This is also a second reason that they accept according to the acceptable reason document. So one of these two is fine. All right. Then we just need to solve for x. We know how to solve for x because in grade 8 and 9, hey, we did solve for x. We are masters of solving for x. We add the like terms for the variable x. We add the like terms for the numerical angles. So we have x plus 3x plus 4x, that gives us 8x. We have 30 plus 90, which is 120. 120 plus 40, 120 plus 40 gives us 160. And all we do now is we transpose the angle negative. Positive 160, transpose it, becomes negative 160 on the right hand side. This gives us a beautiful 200 what? Degrees. We divide both sides by what? By the coefficient of x, which is 8. So then we know x is equal to, you divide both sides by 8, what do we get? What's 200 divided by 8? Flower girl, you girl with flowers. Flower girl, I almost feel like you need to get your flowers, you, eh? I think we need to give you your flowers. Yeah. You've been so spot on in your answers in the comment section. Like, you are so active, you know, engagement is happening hectically there, you know. So thank you. Beautiful. Nicely said, flower girl. All right. Okay. So yeah, marks in the back. You know, as we smile into the maths marks bag, and we are like, hey, I've collected the marks. They are so beautiful there inside this maths bag of mine. My level is just flowing, it's going up, and all of that stuff. Let's look at this diagram. There we have it. We've got PQ, which is a line there, and we've got RS, which is a line there. These two lines, what do we know about them? Look at them. They've got those arrows. What do those arrows stand for? Do we know symbolically what those arrows mean about the lines? Yo, look at flower girl. Parallel. Very good, flower girl. Neo, and Mbali. Yes, 100%. No, Ntati. They don't mean perpendicular. If you have arrows on the lines, my good friend Ntati, that means parallel. You know, how I wish boys and girls in school would be like parallel lines. We are in the same building in that school, but what happens? We are apart, we do not touch, we go in the same direction, progressing in our academic journey to success, but we never touch in the process. This is my female, this is my males, all in school. They are separate and apart, moving in the same direction as we progress towards academic excellence. How I wish all schools could be like parallel lines, and all boys and girls in schools would be like parallel lines, never touching, never doing any funny business. This is beautiful, guys. Parallel lines can teach us a lot. But you know what? There is a healthy relationship between the angles that exist for parallel lines. We have three beautiful relationships. There's a Z-shaped relationship, we call it alternate angles. There is a U-shaped relationship, we call it co-interior angles. And then there is a F-shaped relationship that we call corresponding. Okay, so these angles here that we have listed have a relationship, you know, yeah. So parallel lines have healthy relationships. Just like in school, boys and girls apart can have good wholesome relationships, good friendships, friendships that basically give support to each other, especially in the rigorous academic journey that we all have to embark on. We all want excellence. We support each other in a healthy way. Those relationships are good, not the other one where there is touching, because you see, parallel lines only have healthy relationships. So this here, this x and this x plus 55 degrees give rise to which relationship? Z-shape, alternate angles, corresponding angles, F-shape, or U-shape, co-interior angles. Which relationship exists between these two angles? Now, there is the parallel line. We go down and then we turn into the angle. I'm sure you can see what letter results here. This angle here, that angle there, from the Z. So I see the people commenting, Z shape, Tebucho says, alternate angles. Flower girl, yo, hi flower girl, hi winner, hi flower girl. Guys, flower girl, you just need to just check out flower girl. Flower girl is saying alternate angles, and then she is stating the lines that are parallel. That's what we want most whenever we use this particular reason. We need to state the lines that are parallel. So in my mathematical statement, this angle and that angle are alternate angles. These angles are in that position that gives rise to what we refer to as alternate angles. So therefore, what do we say in our statement? All we simply say is we say 2x is equal to x plus 55 degrees. What is the reason? Flower Girl said it well there in the comment section. We say alt angles, we then write a semicolon, and then we state the lines that are parallel, which means PQ is parallel to RS. Very, very important. So Flower Girl, thank you so much, right? And the Flower Girl, good thing that you are stating the lines are parallel. It's not good to just say alternate angles, full stop. We must say alternate angles, and then we need to state the lines that are parallel. Okay, so therefore 2x is equal to x plus 55 degrees. Now we are in the position to do what? To solve. So 2x must be joined by the x. When it transposes, it becomes negative x. 2x minus x gives us x, so x is equal to, I'm sure you can see, guys, x is equal to 55 degrees. All right, and I think, yeah, Uzimile had stated that. Thank you so much, Zimile. That after we transpose, we get x is equal to 55 degrees. And that's very, very spot on. Okay, statement, reason. Statement, reason with the lines that are parallel. Remember, like I said, and I repeat, parallel lines. Oh, how I wish all schools having all those boys and girls, the boys and the girls would just be parallel lines now and forevermore. Why? Don't touch, because parallel lines never touch, they never meet. We seeing each other, we see, oh, there you are, oh, you exist, oh, there you are, you exist. Let us just ensure that there are healthy relationships existing between the two. Yeah, like for instance, there's alternate angle relationships existing, the Z-shaped relationship. We have the F-shaped relationship, corresponding angles. We have the U-shaped relationship, co-interior angles that are supplementary. So it's better to nurture and nourish those. So in our academic journey, boys and girls, let us nurture the relationships that will ensure that our academic success and also our futures can be cultivated and be better and brighter for the best. Let's move on to the next one. Number 6. All right, can you see this diagram here? I hope you can see, guys, the diagram. Yeah, very nice there, that diagram. I'm sure you can see what you see. There's AB, there's CD. Oh my goodness, those arrows are there again. Do we still remember what they mean? And then there's this line here that's called the transversal line. It actually cuts, you know, your parallel lines. So I can see in the comment section, Tebucho says F shape and then corresponding angles. Mike says corresponding angles. Smart Study says corresponding angles. Flower Girl, as usual, says corresponding angles and states the lines that are parallel. Guys, I hope you guys are taking notes from Flower Girl. It's going to be as if I know Flower Girl and I'm just trying to hype her up. No, guys, it has nothing to do with that. It has to do with accuracy. Maths is about making sure that once you know your stuff, you are accurate all the time. You are consistently accurate. Okay. So Betty, my good friend Betty there, U shape does not apply here. F shape applies. And let us trace, you can see, right? YF, because underneath this parallel line, there's 3x minus 10. Underneath this top parallel line, there's x plus 20. We call this bottom, 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 corresponding. Also, let's say if there was top, top, we know top, top will also be corresponding. So this is F shape, corresponding angles. It is not U shape, because remember, U shape must be angles within the parallel lines. Here we have angles bottom of one parallel line, bottom of the other parallel line. That's why I call corresponding angles bottom, bottom, equal. If there was top, top, we'd say also equal. F only has to do with bottom, bottom, bottom of this line, bottom of that line, on the same side of the transversal line, corresponding. Okay? So these people who are not so sure about U, Z, or F, please, guys, that's why for the grade 10s, I'm reviewing the results we had established in the earlier grades. We all need now to become 100% masters of the geometry in earlier grades. We can't move on with the grade 10 geometry and we are not masters. 100% masters of the previous grades geometry, 8 and 9. So x plus 20 and 3x minus 10 show a corresponding angle relationship. Hold on, guys. Okay, I'm sorry guys. Sorry about that. I had to attend to something quickly. Thought something had happened. But yeah, it wasn't what I thought. Okay. So like I said, grade 10 learners, hopefully we get this F shape. So what do we then say here? We can say x plus 20 degrees, bottom of this parallel line. Okay, guys, this line here, this line that is in line with my pen is called the transversal line. Okay, so we look at the F from the right side. We don't look at F for right and left. No, we're looking at the right side alone. When we look at the right side of this line, the transversal line, we have this parallel line. Bottom of this parallel line, there's this angle, x plus 20. Bottom of this parallel line, there's this angle, 3x minus 10. We call these angles corresponding angles. They are equal if the lines are what? Are parallel. People, this idea of corresponding angles, let me just make a note here. If this angle I have, look at this, right? This angle and this angle are corresponding angles because bottom of this line there's this angle, bottom of this line there's this angle. Whether the lines are parallel or not, we still call these corresponding angles. But we say those corresponding angles are equal if what? If the lines that are there are parallel. The minute the lines are parallel, we can then say these angles that are corresponding are equal. So that's why, for instance, we can say x plus 20 degrees is equal to 3x minus 10 degrees. Why do we say so? We say corresp angles. For corresponding is short, and then we state the lines that are parallel. AB is parallel to CD. AB parallel to CD. That reason is complete and full. But we can't just say corresponding angles alone. We can't just say corresponding angles equal. That is not the reason. The reason is we write corresponding angles, then semicolon, we state the lines that are parallel. So statement, reason. Now we then solve for x. And guys, really and truly, we just transpose x minus 3x. On the other side, have minus 10 minus 20 degrees. We know this is negative 2x with negative 30 degrees. And then we divide both sides by what? By negative 2. Then we state x is equal to 15 degrees. Yes, Tebucho. If the lines are apart and instead of one arrow there is two, this still means parallel. Even if they have three, if the lines are apart, it means those two lines are parallel. Okay, very important, that thing that you are saying. Okay, right. Yeah, x is equal to 15 degrees. And really and truly, that was simple. Say, is it possible if maybe they ask why are they parallel? Why are they parallel? No. If ever they ask you, why are these lines parallel? Remember, sometimes you are asked in a question to prove that the lines are parallel. And in actual fact, maybe in that particular diagram, it's not given that the lines are parallel. Then in some way, you need to find angles that are either corresponding and are equal, or co-interior and are supplementary, or they are alternate and they are equal. Because if you can locate those sorts of angles, then you can state that those lines are parallel and you can give the reason. Alternate angles equal if it was alternate angles that you found. Okay, I'm gonna look at specific examples, for that. But I mean, if they gave you a question like this and they asked you, why is AB parallel to CD? I mean, you would say AB is parallel to CD. It's given, because it is given to you that these lines are parallel. Okay, so they would never, if they ask you that, then you just tell them it's because it's given that they are parallel. Okay, but we'll look at questions that have to do with proving lines, whether lines are parallel or not. In these particular questions, I'm just merely leading us in how to find something that is unknown. So this is still very basic. Okay, let's go to number 7. Yo guys, I'm sorry, the noise, like I said, there is all sorts of activity happening outside here. There's always things happening, and I'm very sorry. Okay, Mickey there is leading the front there. So we've got KL, we've got MN. Mickey, nice stuff. Mickey has already munched things up for us there. Mickey says co-interior angles, because these add up to 180 degrees. Hey, and look at Mickey also stating the lines that are parallel. I feel like people are catching on to the fire that Flower Girl laid out in the beginning. Smart study. Flower boy. Oh, my soul, are you kidding me? I think that is basically that in and of itself, smart study, I think is that is a compliment to Mickey, because Flower Girl was the one doing the things, but I see we have Flower Boy here. But please guys, let's keep Flower Girl and Flower Boy as parallel lines. We don't want any intersection, right? Okay, so KL and MN, very true. What relationship exists between these two angles? So you can see guys that this one is the U shape, the U shape. They are inside the angles, inside the parallel lines. So these angles, I call them the armpit angles. If you extend your two arms in front of you in a parallel state, and then you smell one armpit on the right, you smell the other armpit on the left, these are like your armpits. They smell, right? So we call these co-interior angles. So what do we know about the relationship of these co-interior angles? They add up to 180. So very nice. I love what Mickey has led us. X plus 43 degrees plus X plus 17 degrees is equal to 180. What's the reason? We say co-int angles, and then we state the lines that are parallel. KL is parallel to MN. If we are doing this, then Tina, we are winners. I don't care what anybody says. We are winners. We are winners. We are winners. So yeah, Flower Girl has really helped us out there, you know, because Flower Girl has been consistently in the comment section just stating the lines that are parallel. Now I'm sure everybody is like, okay, hey, me say I used to not even state the lines that are parallel. I would write co-interior angles and I would say that's fine. No guys, you need to state the lines that are parallel. All right, yeah. So this is us laying the foundation for the future, because we want to be those grade 11s and grade 12s and grade 10s that are just amazing in mathematics. X plus X, 2X. 43 plus 17 degrees, obviously that is 60 degrees, which are 180. We transpose the 60, we get 120. We know, guys, you know, you see the maths is happening in a mental state, just happening in the head. The 60 I transpose, I know 180 minus 60 gives me 120. And the maths is just happening in a mental state. That's all. We divide both sides by 2, X becomes 60 degrees. You can see now the maths is happening in a mental state, you know. It's happening there in the head. X plus 43 plus X plus 17 degrees equal to 180 degrees. Our statement is beautifully said. Our reason, oh, those lines that are parallel, guys, they're so amazing. It's just beautiful. I mean, who would have thought like that we would be doing something as amazing as this, you know? All right, next up, who's gonna be next in line? Look at this diagram. Okay, yeah. Now the thing I want people to check for me in this diagram, are you guys happy with the detail that's in this diagram? And do you guys feel that everything is fine? Or is there something that you are feeling like, hey, sir, Could you perhaps do this? Like, look at this diagram. Or do you guys feel like it's fine, it's complete? Anyways, you need to find A, you need to find B, you need to find C, you need to find D, you need to find E. All right? Is there anything that might perhaps be missing in this diagram that you feel like, this is missing? Okay. Okay, you have line A, B, C. Yes. Landiwe, look at that. Landiwe was the first one on the dial. No, there are no parallels. Okay? Guys, yes, the diagram was supposed to actually have had lines that are parallel. Okay? Yes. Yes. Zizi, I love what you are saying in the comment. That is very fun. Such a game, such a beautiful game to play. Yes, sir. All right. So I hope you guys can see that now. The lines that are parallel. So I've put them in, all right? And hopefully that can facilitate us being able to move and get the answers. Now, what's beautiful about Euclidean geometry is that there are, you could pretty much take a variety of ways to getting your values. There's a variety of ways. It's not like there's one way to getting to the answer, but it all is so dependent. What does this many ways, the way to getting to the answer will all depend on how well you know your maths from previous grades. If your maths from previous grades, the geometry that you did in previous grades, if all the relationships for the lines you know, all the relationships between the parallel lines you know, all the relationships with triangles you know, then I'm telling you guys, you look at this, you can already see the answer popping left, right, and center. Okay, so in as much as, we can see the answers, of course, those answers of ours, as we do the question and as we move from one letter to the other, we need to state the reason that is appropriate. Okay, so yeah, I'm just giving people a chance. I'm seeing what's comment section is happening there. Samuel Matthews, for instance, said A is equal to 70, C is equal to 50, E is equal to 60. Okay, all right, and we are missing still B and D. Okay, but of course, what we do needs to move from one step to the other. And Liso, no, it's fine. I'm giving you a chance. I did not even confirm whether those answers are right or not. So I'm giving you 5 minutes, guys, to actually, if you are seeing this problem for the first time, I'm giving you a chance to actually find the values of A, B, C, D, and E. Right? And then once you have completed everything, I'd love a few of you to come up as guests and actually talk to me. We want to hear your voice. Talk to us as to how you were able to get your values and each step that you took as you took that approach. This is Euclidean geometry for grade 10 specifically, but we are revising grade 8 and 9 because for grade 10s, if the grade 8 and 9 is not safe for the grade 10 learner that is here, then we are going to have serious problems as we move forward. So we need to make sure that the grade 8 and 9 is fine. How we state what we state, how we use the reason, the appropriate reason, the acceptable reason. Even for a grade 10 and 11 and a 12 learner, your grade 8 and 9 geometry needs to be sorted. Okay? Needs to be sorted. Yes, I do live lessons for grade 12. But yeah, it's been rare lately because the focus really has been on grade. Lately it's been grade 9, grade 10, grade 11, grade 9, grade 10, grade 11. Because I have a lot of grade 9, 10, and 11 learners that basically always, are so active and eager. So as a result, my attention does tend to be focused on them. But yes, grade 12 I offer, definitely. Okay. Yeah. So please, guys, request the minute you are able to finish, request. I'd like to take you up and you can actually lead us as to how you were able to get to your answers, your different values. Okay. So I am going to do this for excitement purposes. I am going to switch off my comment section. I'm going to switch him off. Where is the switch off button? Let us switch you off, your comment section. Here you go, comment section switched off. All right, I have a few people, it seems like. Okay, definitely Flower Girl needs to get a chance. Flower Girl has requested, so let's give Flower Girl a chance. And I'm going to write down what you say step by step. Flower Girl, hello.
Hi, sir.
How are you?
I'm good, and you?
I'm doing swell. Are you really in grade 10, or are you maybe in a grade higher and you are just chowing the meat for the kids?
No, I'm in grade 10.
Are you sure?
Yes. You know me
Oh,
as
okay.
goodness.
Oh, okay. All right. Okay.
Yes.
All right. No, beautiful. Okay. All right. Do you want to lead us step by step?
Yes.
Okay, let's start. Where did you start?
I did it alphabetically from
That's
A.
beautiful. Ah, that's even more beautiful if you did it alphabetically. Not that you don't, you must do it alphabetically. Sometimes, doing it in another way is fine. But as long as there's order and there's logic in how you are able to move from one place to the other. So let's go. Lead us.
Okay. So for A, I first said 110 degrees plus A equals to 180 degrees because the reason is angles on a straight line.
Okay, let's stop right there for a moment so that our beautiful viewers can sort of appreciate this, what you've said. You said 110 degrees, which is the angle here, plus this A, which is the angle there. And I love what you've said here, because from here to there, and then from that point back to the straight line, these two angles are adjacent. They are next to each other. So when we do add them, indeed what you have said is 100% spot on. 110 plus A is equal to 180 degrees. And your reason, you said angles on a straight line. I agree. Thank you. Let's move.
Then I got the answer as 70 degrees.
Okay, beautiful. Beautiful. A is 70 degrees. So people, I just wrote down, I'm writing down what Flower Girl is writing down. That was her statement. That is the reason, according to that acceptable reason document, angles on a straight line. And then obviously when we solve, we transpose the 110, we get A is 70. Nice. Then what we do is we update our diagram so that the new information, hopefully it's accurate, guys. It's always nice when the answer is accurate. Then when we update with correct information. Next.
For B, I said 110 degrees plus B equals to 180 because co-interior angles in which AC is parallel to DG, I think.
Whoa. Okay, let's pause for a moment, then just take in what you said there. You said 110 degrees plus B is equal to
180
180 degrees. Reason?
co-interior angles in
Okay.
which AC is parallel to DG, I think.
Okay, AC parallel to DG. Now, I just want to check co-interior. We know co-interior means U shape. So that's our parallel line. We're going down the side, back. That's the parallel line. So that forms a U shape. Nice. So B and 110 between the parallel lines does form a co-interior angle relationship. Our armpits, B plus 110 is equal to 180. You said co-interior angles And then beautifully stated as well, you stated the lines that are parallel as AC parallel to DG. Sure, flower girl. You are chowing here. Yes, let's move.
So B will be equal to 70 degrees.
B is equal to 70 degrees as well. Of course, guys, I'm sure you can see that we transpose the 110. 180 minus 110 give us B, which is 70 degrees. So yes, flower girl, thank you so much. B is 70 degrees. Update the diagram. I've got 70 there now. All right. Okay. Let's pause for a moment there, flower girl. I just want to check. Do we see that alternatively, if we wanted to, because we got A is 70, there's also a relationship that exists between the B and the A.
A,
Yeah. So someone else, if they wanted to, could have said alternate angles. B
yeah,
is 70, alternate angles. Okay. That's just for someone else who would have seen something different. That's correct as well. You are correct, flower girl. That other person who would have thought that alternatively would have also been 100% spot on. Okay, let's move. Flower girl, you're going good. We are going very nice.
C plus 130 degrees is equals to 180 degrees
Okay.
and on a straight line.
All right, C, this angle here, plus 130, yes. Two angles next to each other. Okay, they are separated by this transversal line. C and 130 are adjacent angles. They are on a straight line. They do indeed add up to 180 degrees. So, hey, flower girl, I don't know. Me, I'm smelling that. I don't know if we can say that you are really great then. You're sure? You sure?
I'm 100% sure.
All right. So C plus 130 is equal to 180 degrees angles on a straight line. Yeah. And then
C will be equals to 50 degrees.
all right, epic. Yes, indeed. C is equal to 50 degrees because if we transpose 180 minus the 130 will give us the 50 degrees. So indeed, C is equal to 50 degrees. Beautiful. Update our diagram as we ought to update it. There we have it. We've got two more letters to go.
Okay. C is equals to angle D, which is equal to 50 degrees because alternate angles in which AC is parallel to DG.
All right. Sure. Okay. Guys, I'm sure you heard the power in those words. Very confidently said. C is equal to D, right? What relationship exists? It's our Z relationship. There it is. This angle is equal to that angle. C is equal to D, which is equal to 50 degrees. Reason? Alt angles. Then we state our lines that are parallel. AC is parallel to DD. Nice. Update the diagram. 50 degrees. Someone else could have used co-interior angles as well. All right. 130 plus that angle. Okay. It would have also been fine. Okay. Now we need E.
Okay. Angle A plus C plus E is equal to 180 degrees interior angles of a triangle.
All right. Nice. So in that triangle, what triangle is that? It's BEF. So in
Yes.
triangle BEF, you are saying A plus C plus E is equal to 180 degrees. And your reason is?
Interior angles of a triangle.
Thank you. I love that reason. That's my favorite reason. Interior angle of a triangle. I know some people say sum of angles in a triangle. That's also acceptable. or angle sum in triangle, that's also acceptable because we have those three separate acceptable reasons that we can use if we don't use any other. We don't use any other but those. So that's 70 plus 50 plus E would be equal to 180. 180 minus 120. That says E is equal to what?
60 degrees.
Beautiful. Ish, flower girl. I flower, you are doing the things here. Yeah. Thank you so much. That was amazing. Very well done. So that's everything 100% spot on there. Someone else could have used angles in a straight line. You have the 50, you have the B, you have the E. Remember these three angles, 1, 2, back to the straight line. You add those three angles, they should also give you 180 degrees. Angles on a straight line would have also been fine. And also, like I said, guys, someone else could have approached this totally in a different order, not necessarily in alphabetical order, as long as there is logical development of the answer from one place to the other. And we can always use the values that we update to be able to get the next and the next and the next, which is why it's so important to do things accurately as you go about doing these. Flower girl, I am giving you your flowers today. I.
Thank you, sir.
Yeah, beautifully done. I'm gonna let you go. Thank you so much. Really appreciate that.
Thank you, sir.
Okay, so we're back here at number 8. Let me just restore back my comment section. I just wanted to avoid commentary and stuff. I'm sure everybody else is like so pleased with how well Flower Girl was able to do that problem. They were logically done. One step, one part following the other. This is what we want, guys, because Euclidean geometry is all about logic, applying theorems in a logical manner, you know. So the way that was done, this is basically what Flower Girl developed for us. All right, very well done. Okay, very well done. Therefore, E is equal to 160 degrees. How? How is E equal to 160? E is equal to 60 degrees. Okay, 180 minus 120 is 60, not 160. I didn't say 160. Okay, all right. Okay, let's move on to the next one. This is the next diagram, guys. Okay, let's give people a chance there. We've got AB, we've got CB, we've got CD, we have DE, and we have FG. Shoni, I don't know what time. Guys, just so that you know, the thing is I've been held hostage by Vodacom. I don't know if you guys are experiencing the same thing, but I've been experiencing a topsy-turvy roller coaster affair with Vodacom. Lately, I've really been struggling. Like there are times in the day when my Vodacom network it goes off the grid completely and I have no network. You know, now all of a sudden it's back. So I am really literally held hostage by Vodacom. So for me to say what time I'm going to host the next and the next, I cannot say. You know, it is when Vodacom network allows me in my area. Okay. All right. So please, I'm sorry I cannot tell you the specific time when the next one will be, but for grade 10s, this is the only session we'll have today for grade 10s. Okay, guys, we need to find C, small letter C, small letter B, small letter A. We are given this 74 degrees, and I'm sure you guys can see FG is a parallel line, DE is a parallel line, CB is a parallel line. And apparently this line and this line and this line, they are parallel. And then CF, it's got the double arrows with AB, which means this line is parallel to that one. So now we need to find A, B, and C. And we are only given 74 degrees as this angle. So I need a brave one to avail themselves. I think anyone besides our flower girl there who can actually assist us in answering this one. You can come up and actually lead us. Okay, and this is the last sort of like parallel line type question I'd like people to actually hop on and they can actually lead us as to how they got their values A, B, and C. We need this angle, we need that angle, we need that angle. How do you request? Oh, Shem, Mike. Mike, it seems like what's happening there? Because I just checked out your. It seems like you can't. I can't request you. I don't know why. Unfortunately, I don't know why. Because I wanted to. Yeah, I don't know why it's not feasible to. Okay. Okay, Landio, I can actually extend the request to you. It's happening. So I've just extended that to you. Oh, so Mike, you need to make your account not private. That's why you must make your account public. Then I can send you a request. Unfortunately, if you are private, it means you are going to a private school and you are privatizing yourself. No, I'm just kidding. It just means that I cannot have access, okay, to extending an invite to you. Landio, it seems like your network is playing. It's playing that game, hey? We were trying, it was saying, and then boom, gone. I'm gonna try you one more time. I think your network is playing as well. It's playing that game. Yeah, I never know when mine is going to decide to just sort of switch off and not conform. All right, there we are. We've got you, Landio.
Can I start?
Yeah, please go ahead.
Okay, for A.
Okay.
For A, we can start by alternate angles. So it's gonna be 75 degrees is equals to A. A is equals to 75 degrees. If, alternate angles reason. If
Okay, so we have
FG is parallel to DE.
So this is what angle? This is 70.
Sir,
You said A is 70? Landio,
4 degrees is equals to A.
Okay, you said A is equal to?
Sir, my network.
I know, hey, I know. But just say that again.
74 degrees.
Thank you. A is equal to
Reason alternate angles.
Okay, reason alternate angles. That's true. And we need to state something else.
Yes.
After alternate angles.
If FG is parallel to ED.
Okay, FG is parallel to ED. Okay. 100%. So please
then
make sure
we can use
A is 74 degrees, alt angles, and then you state the lines that are parallel. FG is parallel to ED. Okay. Update. Move on.
then for B we can first use the angle A to find the other angle. Reason straight lines.
Wait. You are saying we can use what?
So it's gonna be A is equals to X. We can put X there, sir.
A is equal to X.
A plus X. We can put X next to.
So you want to put in another variable here.
So that we can. Yes, X.
Okay, let me just do what you're saying I must do.
Yes,
so
X.
Oh,
sorry. We can use corresponding angles, foot.
Okay, so which one are you using? Are you using the one with the X or are you using what you just said? Which one do you want me to say?
Let's use the given corresponding angles.
Corresponding angles. You see corresponding angles. Where do you see corresponding
Yes,
angles? Is there corresponding angles?
there. Yes, so there's F there.
Is it? So this here.
Yes, to find B.
Oh, I see now. Okay. So this A and this B, F corresponding. So
Yes.
bottom, bottom.
Yes.
Oh,
Yes.
okay. So B
So
is equal
A
to?
is equals to B.
Which is equal to what?
A,
Which is what?
74 degrees if corresponding angles.
Yes.
If CB is parallel to DE.
CB is parallel to DE. Okay. So B
Yes.
is equal to A is equal to 74 degrees. Reason corresponding angles CB parallel to DE. All right. Though you've said that, I'm interested in what you were saying earlier on because I think it was the comment section. I should have switched off the comment section if I knew from the beginning. Sorry, because I wanted to roll with what you were saying. I was interested in that fact, so I'm going to switch off the the comment section now.
I can do it, sir. I wanted to say that A, ne? Then
So
we can
this
put
A.
another variable. Yes, we can put another variable there.
So you wanted to put X.
So it's gonna be, yes.
So
So
you
it's
were
gonna
going to
be
let-
X.
So you were going to let what?
Let angle.
Because that's important,
Yo.
eh? Remember, when you introduce a variable, if you choose to introduce a variable, you need to actually reveal to me as the person that is marking you. You need to tell me, what are you letting?
So can I write like, okay, so can I say D1 and D2?
Now, here's another thing I need to explain very quickly. The whole idea of D1 and D2, we only use that if the diagram has those in it already. We can't introduce those ourselves. So in the diagram, there must be D1 and D2 in order for us to use D1 and D2. But if in the diagram we don't have that, then we need to you need to tell me what this angle is in relation to the letters that you have. Okay, so this would be angle what? This angle. It would be angle.
CDE.
Thank you, Landiwe. It's very important, that thing. Okay, please, this idea of using D1, D2, D3, you don't introduce the numbers yourself. The numbers must be given in the diagram for you to use D1, D2, D3, and all these other numbers. All right,
Yes,
they
sir.
must be there. But if those numbers are not there, then you need to use the letters to be able to name or specify the angle you are talking about. So yes, like you said, you can either say angle CDE or you can say EDC.
C, yes, sir.
And I mean, that's basically it. So we let CDE be equal to X.
X.
I don't have a problem
Yes,
with that.
sir.
Then I'm listening.
Then we say X plus A
X
is
plus.
equals.
Now, you already have the A, Mos. You already found what A was.
So
what?
I can get to the point, ne?
Yeah, get
okay,
to the
74
point.
okay.
Yeah, get to the point. If you have you did a previous question, you got A, so now we don't waste our time. We get to the point because time also becomes a problem sometimes. So X plus 74.
Yes, is equals to 180 degrees.
All right, reason.
Raising angles on a straight line.
Okay, angles on a straight line. I'm listening. So
then, yeah, X is equals to 180 minus 74.
yes, I'm listening.
I don't have my calculator with me.
No problem. 180 minus 74 will give us 106.
Yes. Then from there.
Okay, I'm back there. The diagram now I update 106. Then what were you gonna say after?
From there, we use co-interior angles.
Okay.
So it's gonna be B plus 106
Thank you.
is
Getting
equals
the
to
point.
180 degrees.
You. And then reason?
Co-interior angles
Yes.
if CB is parallel to DE.
Okay, thank you. Right, then we solve for B. B is equal to what then? 180 minus
Did you get that?
180 minus 106, which is equal to 74 degrees. Hey. Now, I want to come back to you, Landiwele. I see the method that you use, okay?
Yes.
Yeah, but the only concern I have with it, it's long. Okay? Check it how much I
Yes,
have to write.
I saw my mistake.
No, it's not a mistake, Landiwe. It's not a mistake. It's not a mistake. It's this what you've done is fine. The only thing I am concerned about is the amount of time you are going to be spending answering this question. Have you ever written a test, Landiwe, at school and then you felt like you didn't have enough time and you didn't finish the test?
Yes, I always.
You see that always. That always needs to end, Landiwe. The reason why that happens a lot to students.
It needs to end there.
Yes, it has to end. The reason why that happens a lot to students is because they sometimes use long ways to get answers and they spend a lot of time answering as a question that they probably should be spending 30 seconds in answering. So look at someone who is able to see after finding A that there's a relationship between A and B and it is corresponding angles. Look, how much did it take me? One line, one statement, one reason, done, finished. How much time did this person spend answering this question? You see,
30 seconds.
I'm telling you, 30 seconds, and then moving on to the next question, you know? And when you are there, still writing your essay, the essay. Still writing the essay.
The answer is correct.
No. Don't get me wrong. I am not. Did I say to you you were wrong? No, I didn't say that. I'm just saying that we need to use the method that will basically get us there quicker, especially for something like this, because at the end of the day, the more time we are able to spend, the less time we're able to spend on these, then the better it is for us. Then it will give us the chance to go to the other problems and do them. And the teacher won't have to say, time's up, and you're like, yo, I'm still in question 1. You see? Yeah, because that's a
Okay, sir.
I don't know how painful it is for you to have actually seen yourself in a situation where you're like, and then what the worst part about it all is that you finish that paper, you hand it in, and then you actually look at the paper again and you're like, I could have answered question 2. I could have answered question 3. Question 4 was easy. Yeah, and it's a painful thing, that thing. So I'm just saying that, yeah, let's see what we need to see. So that's why it's important to know your stuff, because the person who sees corresponding angles, life is easy. Let's finish off, Landiwe. We know that's 74. Let's update the diagram. We need C. And you can see what I did, Landiwe. Do you see that I've changed the orientation of my paper? Just wait, Landiwe. What I did is I took my paper and I placed it in this direction so that I can start seeing what I need to see. I didn't allow it to stay like this. I changed it up. Yeah. So sometimes in Euclidean geometry, you have to take your paper and you move it like this and that and this, you see, so that you can finally see what needs to be seen. Now it's back in this direction. I want C. What's C?
So C is equals to B.
Amen.
Reason alternate angles.
Oh my goodness. C is equal to B. And the actual angle is 74 degrees.
Network. Can you hear me?
I am hearing you very well.
Can you hear me,
Yes, I can.
sir?
Yes, I can hear you. Yeah, we're probably having a lag there. Okay, but I heard you. C is equal to B is equal to 74, alternate angles, and then the lines that are parallel are AB and CF. Okay, yeah,
Angles. If AB is equals
it's parallel to CF.
CF.
CF, yeah. Okay,
Done.
all right. Done, Landy. Three statements with 3 reasons. Straight to the point. All right. Okay. Landy, I'm going to let you down. Thank you so much. Okay, I think there's a delay there, but Landy, thank you so much. I'll let you down there. All right. Okay, let's move along, guys, to the next and the next. Let's allow the comments there to come back on. Maybe it's my network, my side. Okay, it's not. Okay. Guys, now we enter into the world of triangles. So we've got 10, 11, 12, 13, 14, and 15. So let's look at 10. I think Kamzaga Jimen. Is it Kamzaga Jimen? let's get some males in the house here. I think the females have been doing the most there. Okay, network. Tyreek Bodibe, you're welcome, buddy. Thank you so much. That's very kind of you, sir. Very, very kind. Thank you so much. Really appreciate that comment. Yeah, I feel like people that come here are very generous. This is for grade 10, but of course we are accommodating. I mean, whatever grade you are in, this obviously these basics you need. It's something that you need to know very well. Kabelo,
Hello, sir.
the Mr. Snapman, are you good?
I'm good, sir. And you?
No, I'm doing awesome, bro. I'm doing awesome. No problem. No problem. Are you in grade 10 for sure? I don't want grade 12s here and grade 11s trying to showcase steal the thunder of the grade 10s.
Yes.
All right. Hopefully you are telling me the truth. Let's move, Geparada. I need you to lead me along. I think all 10, 11, 12, you can do these most. Let's go. We want X. We have triangle ABC. These lines mean something for the triangle. So let's go.
Okay. They given us AB is equals to AC.
AB is equal to AC. Yes, that's given.
Angle.
Let's go.
So which means angle C is 56.
Angle C is 56 degrees. What's the reason?
The reason is AB is equals to AC. Those lines that is cross.
Okay, AB is equal to AC, but I need a stronger reason than that. There's something that we have there, the acceptable reason document. Okay, so what I said is AB is equal to AC. That's given. Very good.
Yeah.
Now I'm saying angle C is equal to 56 degrees. I need a reason.
That reason is isosceles angle or
Isosceles angles. Okay, that one we are kicking out of the reason box in grade 10. We are fighting that reason. We are no longer accepting that reason. Maybe in grade 9 we may have been a bit accepting, but in grade 10, 11, and 12 there is a reason here that we accept wholeheartedly, and that is the only reason we accept. Darkila Cute in the comment section has given us that reason. So
opposite angle are equal. Thanks, man.
angles opposite equal side.
Yes.
This is the reason we accept. Okay, so we no longer use base angles of an isosceles triangle. Base angles of an isosceles triangle, we don't play with that one anymore. Isosceles triangle, angles of an isosceles triangle, no, we don't accept that one anymore. All right, we use the acceptable reason that says angles, these two angles, they are opposite equal sides. That's the reason that we use angles opposite equal sides. All right, and that's for all students in South Africa, guys. We use this reason. Everyone must subscribe to the reason. Okay, all right. Thank you. Let's update the diagram. We now have 56 degrees. Okay, then
we'll see. We want x.
Yes, we want x. Yes.
So we'll say x plus 56.
X plus 56.
Let's start with this diagram. We say a plus b plus c is equals to 180. Sum of angle in a triangle.
Okay. Did you say a plus b plus c?
Yeah, it's equals to 180 degrees.
A plus b plus c, or angle a plus angle b?
Angle.
All right. Don't mind me. I'm like this, eh? Don't mind me. Okay, all right. I've done it. Angle A plus angle B plus angle is equal to 180 degrees. And your acceptable reason, any one of those three: interior angles of a triangle, or you can say sum of angles in a triangle, or you can say angle sum in triangle. All right. Then,
so you'll say C is 56 again.
Yeah, C is 56.
Yeah.
Angle A though is?
I don't have a calculator, but I will do it now. Looks 56 plus 56 minus 180.
Okay, so then we have x is equal to 56. Someone in the comment section, let's help my dear brother out. I'm not going to simplistically just do that for us. So 180 minus the 56 minus the 56. It seems like in the comment section there is an agreement of 68 degrees being the answer, my brother.
The 8 degrees. That's x.
Yeah. That's what people are saying there. Okay. And then obviously 56 plus 56 would have been 112. Okay. Thank you so much, guys. Really appreciate it. All I did is I just transposed all those angles over minus 56 minus 56. And then I used the calculator to get 68. Okay. All right, 68 degrees. We are good. I don't know, my friend there disconnected. I don't know if that was on purpose or that was by mistake. I sure hope it was by mistake, not on purpose. Okay, let's move on to 11. And number 11. Okay. This one, guys. What type of triangle? So this triangle, yes, is an isosceles triangle. We agree. This one, DEF, we are asked to find the value of x. Right? Yes, Sabrina, that's an equilateral triangle. Equilateral triangle. Right? So we want the value of x. What is the value of x there? That is definitely an equilateral triangle. So we want the value of x. X is equal to 60 degrees, definitely. What would we say our reason is? Guys, they seem to, in the acceptable reason document, to not really have a specific particular reason that they give us for saying x is equal to 60 degrees. Okay, because we know that one of the properties of a triangle that is equilateral is that its individual angles, each individual angle is equal to 60 degrees. So in all honesty, if I am someone who is looking at a learner's work and a learner says x is equal to 60 degrees straight up and then gives me this as the reason, I give that learner 100%, because that speaks to the learner's understanding of the properties that are attached to a equilateral triangle. If someone else does the following and says x plus x plus x is equal to 180 degrees, that's also fine. And then says sum of angles in a triangle, that's fine as well. Because obviously the reason why they are saying x plus x plus x is because they know that each individual angle for this specific shape, each individual angle would be equal. So that x plus this x gives you 180 degrees, interior angles of a triangle, and then they solve for x. They get 180 divided by that 3, which gives you 60 degrees. That's also 100% fine. So both of these approaches would be okay, and they would both be acceptable. All right. Right. Now I want to move on to this one, this diagram. And I think there's someone here who is dying to come and answer this one. Liema, welcome up, Liema. Liema is very hungry to answer this question. Very hungry to answer this one. This is grade 10, guys. Liema, are you in grade 10?
Yes, sir.
Are you sure you're in grade 10? Why does your big voice seem to give me ideas that you are not in grade 10?
Yeah, maybe puberty reached me at a very early stage. I don't know.
Even the way that you mince words together, my friend, it doesn't speak grade 10, this one.
Okay, sorry, sir, but I was bored. I'm sorry.
No, I'm just kidding, man. If you're in grade 10, then that's fine. I just need integrity. People must tell me the truth. Otherwise, hey, you can see even in the comment section, man, people are saying grade 12. I think there's people thinking you're in varsity, you know?
My network is so bad.
Oh, okay. It's fine, buddy. Can you lead me here? This triangle. I want A and I want B. Oh, the network. Okay. Don't come up here, guys, if you are in grade 12 and all these other grades. You must, if you are in grade 10, you must come up. I don't want people that are in higher grades here stealing the show. Okay? I don't want people stealing the show for the other grades, please. Hello, Kay? Ah, you see? All right. Okay, guys. You didn't buy it. Yeah. Kabelo, you're back.
Say I'm back. Ish.
All right. What happened there? Your network, it killed you.
Ish. Yes, sir.
No problem. Okay, we are here now. We are in this triangle. We want A and we want B.
Okay, angle A, is it 35 or 30?
So this is 35. Okay, that angle here is 35. Obviously, this box means something else, and this A is there.
So
we want A and we want B.
We'll say A.
Okay.
Angle A plus angle C plus angle B is equals to 180. Then the sum of angle in a triangle.
Okay.
Angle C is equals to 90. Then you'll say 35 plus 90 minus 180. Then it gives you A.
Okay, let me just follow you there. You said angle A plus angle B plus angle C is 180 degrees. Yes. So you are specifically looking at triangle ABC.
C.
Okay, so angle A plus angle B plus angle C is 180. And then you said the reason is sum of?
Angle in a triangle.
Okay, all right. Then, after that, you said?
Given angle C is equals to 90 degrees.
Very true.
So you'll say angle A plus angle C.
Right.
Yes. Then you plus them, then you minus 180. They give you.
Thank you. Thank you. So you add the 35 plus 90. The A is equal to 180 minus 125. So what is the answer? What's 180 minus 125? It gives us?
The
55 degrees.
Yeah.
Thank you. Awesome. So we have A. Now we need B.
B. Okay, B is simple. Angle A, you'll say 35 plus 18. Is it 18?
Yes, it's 18.
is 18. Then you plus them, I'm sure they will give you what?
Wait a minute, you said, Kabelo, you said, what do I say here?
Angle A as a whole. Triangle
Angle A as a whole,
let's say
yes.
triangle ABD.
Oh, okay. So we are looking now in triangle. This is very important to say that. In triangle, always identify the triangle you are working in. Okay?
Okay. Yes.
So I'm listening.
So you'll say angle A is 35
Yes.
plus 18.
Angle A, the whole entire angle, angle A, which is 35 plus 18. Yes.
It gives you 53, ne?
Yes.
Then you'll see 53 plus B.
53 plus B.
Which
Yes.
we worked with angle A at B, or is how much?
Yes. And what did we get for A?
We get
We had gotten 55 degrees.
we got 55 degrees plus, so you'll say 50 plus 55 plus B is equals to 180, sum of angle in a triangle.
Very true. Okay.
Yes. Then you say 55 plus 55 minus 180 is give you angle B.
Okay.
Yes. So
Okay, so what's 55 plus that 53?
one 108. You hear me, sir?
Yeah, I'm hearing you.
Let me.
Okay, so this is basically what Kabelo was saying. Angle A plus angle B plus angle D, looking at triangle ABD. Angle A, all right, is that 35 and that 18 degrees. So it's that entire angle. So we have 35 plus 18. Angle B, which is where the small letter A is, that is equal to 55. And then angle D, which is the small letter B, all right,
72.
equal to 180 sum of angles in a triangle. Then what he did is he actually added the constant angles together. Plus B is equal to 180. Then he transposed the addition of these two angles, 180 minus 108, which gives you B, which is 72 degrees. Okay.
Yes. Is it wrong, sir?
No, it's 100% correct. That's fine.
Okay. Okay.
That's 100% fine. You did well. You did well. So that's definitely one approach one can use when answering this specific question. Okay. Smart Study is seeming to say that it's a long road. What would you have done, Smart Study? That's what I want to know.
Okay.
Just wait.
Well,
I want to actually call up someone here because they are saying, no, this is a long road. What would you have said?
let's go to that diagram. I have a short method. Me.
This one. Okay.
I will say I'm working with angle ACD.
ACD.
Yes. You see, they given us C angle ACD is equals to 90 because
True.
of straight line angle.
Yes.
Yes. Then I will say 90 plus 18 plus B is equals to 180. Then I will say 90. The reason is sum of angle in the triangles.
Okay, I see.
Yes. Then I will say 18 plus 90.
Yeah.
And minus 180 is give us B.
Yeah.
Yes.
So that would have also given you 72 degrees.
Yes.
100%.
100%.
In the comment section, there's someone else who's saying you could have also used an exterior angle of a triangle.
Yes. Yes.
This is 90. It's the exterior angle of which two opposite interior angles? 18 and B. So you can say B plus 18 is equal to 90. Reason? Exterior angle of
Angles.
triangle.
Mm.
Yeah, that would have also worked. So if you say B plus 18 degrees is equal to 90 degrees, exterior angle of triangle, that's also fine. Okay, because remember guys, that for a triangle, this here, all right, for triangle ACD, this here is an exterior angle. Remember in grade 8, there's this theorem that says the exterior angle of a triangle is equal to the sum of the two interior opposite angles. But remember that this angle that is exterior must always be in line with the side of that triangle you are referring to. That is the true exterior. All right. So if we say we have A, B, we have C, let's say this is C1, the angle that's exterior is C1, we say angle C1 is equal to angle A plus angle B. And the reason is exterior angle of triangle. So for those people that are lost about the idea of exterior angle, you can use that as well, all right, in this particular diagram to find angle B. Because angle B and this 18 degrees are your two interior opposite angles that whose sum is equal to this exterior angle, which is 90 degrees. Okay. So that is just for the people that are like wondering, Aibo, how do we now use exterior angle of a triangle? We use exterior angle of a triangle because of that very fact. So when you solve this, you take the 18 over, this also gives you 72.
Yes,
Still the
that's
same answer, still correct,
correct.
just a different approach.
Correct.
Okay. Yeah. All right. So Kabelo, thank you for that one. Okay. Thank you for that one. Kabelo, maybe you can lead me with this one as well. All right, and then I'll call on someone else for the next one. This one.
Okay. That one AB plus C is triangle like it.
So this is A, B, C, the triangle, yes, and then there's this Y that's outside the triangle.
Yeah. So we will start to solve for X first after we come to Y.
Very good, nice. I love what you just said. We need to first solve for one variable, then we can move on to the other.
Yes. So we'll see angle A plus angle B plus angle C is equals to 180. Sum of angle in a triangle. Then we solve for X. Say. I think X will be what? Let me calculate.
So I hope you guys heard what
X
Camilo
is
said.
equals to 80. 80. Oh. Let me calculate it carefully.
So Camilo said in triangle ABC, 2x plus this 3x plus this x will give you 180 degrees. The reason is sum of angles in a triangle, all right? And then you add the like terms, 6x you get 180, you divide both sides by 6, the coefficient, you get x is equal to 30 degrees.
Then if we want to solve y, we use that exterior angles is equal to sum of opposite interior.
Okay, you can use exterior is equal to the sum, which two angles?
Are opposite interior.
Yeah, the opposite interiors, which means A and B. So you can say angle A plus angle B is equal to that y. Remember, you have what x is. You were told that x is 30. So that means your 2x becomes 2 times 30. Your 3x becomes 3 times 30.
Y is equal to 150.
Okay. You can see our friend here is very, very swift. Very swift. Therefore, y is equal to 150. That's one way of doing it. Okay, so we could use the exterior angle of a triangle. That's one way of doing it.
Yes. Even straight line will work, sir.
Exactly, very true. That's another way that we could look at. We could use angles in a straight line. Okay, because what can we see here?
X is 30, then 180 minus 30 is give us 150.
Yeah, so from here to there, and then from there back to the straight line. Those angles are next to each other and they are lying on a straight line. So that means we could use that as well. X plus y is equal to 180. Angles on a straight line. And then, of course, we can use the value of x, which we know already is what? Is 30. And then we transpose the y, the 30 degrees. Y is equal to 180 degrees minus the 30 degrees, which gives us 150.
Thank you, sir.
Yeah, thank you as well, man. Thank you, Kabel. Hi, Kabelo, you should be a smarty pants, mostly. I'm sure term 1 maths was just a breeze for you.
Yeah, sir. Yeah.
It was a breeze
We
for
are
you. I'm sure
trying.
you were trying.
Yeah,
Yeah.
trying.
Do I dare ask you the famous question about your term 1 results for maths?
No problem.
What did you get for term 1? What did
I get level 7, sir.
you got level 7? Which one? Which level 7? Was it the hot level 7 or the cold level 7?
Ish. Hey. You the quad, sir. It's not the fault. Because
Which one? Which one? Which one was it?
It's just 82.
82. Oh, all right. No, that level 7 is a very good level 7, by the way. Yeah. You see now in maths they are categorizing the level 7s. They are saying there's entry level 7 that is cold, and then there's hot level 7.
Yes.
So the cold level 7 is your 80 to 89. You see, like, I mean, we celebrate and we rejoice when people get level 7, generally speaking. But there's the hot level 7. You see, 90 to 99. 90 to 99 is the hot zone.
Yes.
Yeah. So we always encourage those people that are regulars. The people that are regulars at level 7 must always aspire for the hot zone. The hot zone is the place to be. Yeah. Yeah, but yeah, you keep that up, buddy. Like, I think if you keep up the momentum, like you are keeping it up, and you do what you need to do, I'm sure you will be talking a different story term 2 June exams.
Yes, thanks.
Yeah, man. Everything of the best, KB.
I'm leaving.
You are leaving?
I'm leaving.
Oh, okay.
Thanks.
Sure, man. Okay, thank you so much, Smart Study, for that. The ice cream there. See that in the comment. Really appreciate it. Thank you for the GG as well. Okay, let's move on to the next one. Anyone want to come up for the next and for the next? Yeah, we are wrapping up, by the way. The last two. Okay, maybe if you don't want to come up, you can just tell me in the comment section. We have a triangle. Mr. Stogie.
Good day, sir.
How are you?
I'm good, thanks, and yourself?
I'm doing awesome, man. Doing awesome. Even the better to have you as my guest.
Hey, thank you so much.
So tell me, have you been following through with us? Because we want someone who can help us solve this one. We want the value of x. We are given that triangle. There's a line NML. There's a triangle on it. We want the value of x.
Oh, I can try, Minik. I can
Please,
try.
please try, man.
Since we are looking for the value of x.
Mm-hmm.
Firstly, yes, Minik. Thank you for doing that. Thank you. Yeah, I can say angle M. Can you please name your M into angle M1 and M2?
I'm not going to do that. I just fought with my learners in this live about doing that when it's not provided in the diagram.
Okay, Minik. It's cool.
Yeah. So that's something I
We
yeah.
can start by finding the value of M before.
Which M? What do you mean by M? Do you mean angle KML or do you mean angle KMN?
KML.
KML. Angle KML.
Yes.
Okay.
Then angle K plus angle M plus angle N.
Angle K plus angle M plus angle K plus angle
K and angle M. Angle K plus angle M plus angle L is equal to 180 degrees.
What's the reason?
It's some angles on the table.
Yeah, sum of angles in a
Angle of
triangle.
Yes.
Sum of angles in a triangle. Is that what you said?
Yes, sir.
Okay.
Yes, sir. Then we can substitute 48 plus 48 plus 74.
Yes, I'm
Plus
listening.
angle M equal plus angle M is equal to 180 degrees.
All right.
Then we add 48 and 74.
Which gives us?
Let me check faster. 122.
Okay, then
we transpose that 122 to the
yes.
other side. It will be 180 minus 132. 180 minus 132. Then our angle M
I'm waiting. Angle M is? Okay, so our angle M is 58 degrees, okay? Just something for us to note here together with Kamogelo. Guys, if you are going to use angle K plus angle M plus angle L, remember, angle K here, all right, is this entire angle. Angle M, unless you tell me in triangle KML. If you say in triangle KML, then you can write angle M because if you write this and you say in triangle KML, then you are sending me to the triangle. Inside that triangle, the only angle M that exists is this angle. All right. But if you don't tell me the triangle, then you have to then say angle KML. You have to say angle KML. We don't introduce numbers 1 and 2 if the diagram does not have those numbers. Okay, please, we don't say M1 and M2, but the diagram did not initially have the 1 and the 2. Okay, that's very important, that part. So we must use the letters K, M, L. This is the angle that we are talking about if you are wanting to find this angle. Okay, the only way you can write the angle alone as the letter alone, it's when you have specified the specific triangle you are working in. Okay. So angle M is 58 degrees. So you know what that angle is. Now you want to find the angle, the x value here. So now you can use what to find the value of x. Okay, since Kamukelo got us started on this route, let's complete what he basically had said we should do. Now we can find the value of x because the relationship between this 58 and the x is angles on a straight line. So then we can say x plus 58 degrees is equal to what? 180. And then the reason we say angles on a straight dot line. And then we get x is equal to 180 minus 58 degrees. And we know that our x value, x is equal to 122 degrees. Now, of course, this is a long way of getting to x. I'm sure most of you, when you looked at this question initially, and this is not to, the reason why I'm not, sidelining when people use the long reasons is because I want to obviously appreciate the effort that people are putting in and the approach that they are actually utilizing to get to their respective answers. Okay, so I don't want to dispel or dismiss that effort. It's correct, but then I do want to encourage people to begin to look at diagrams and see, is there possibly an easier approach or an easier way of getting to the answer? And Debucho M in the comment section is basically exposing us to that easier way that we could have used to get the value of x. This is sort of like a long roundabout way, but the easier way, and it only comes about, remember these things of saying the easier way or the shortest method, it's all coming about because we know all of our theorems that have to do with triangles. The thing is, the minute there's something we have forgotten, that will mean that we are going to have to use what we remember to basically get to the answer. But the minute we remember everything and we know everything, then we can actually approach this with the most shortest and accuratest method, if you want to put it that way. So what you see there from Debucho, yes, we can say x is equal to 48 degrees plus 74 from the beginning. This x value is the exterior angle. It is equal to the sum of the two interior opposite angles. These two interior opposite angles are 48 and 74. So adding these two together gives us the value of x. So x is equal to 48 plus 74 degrees, and we state the reason as has been stated there. And then obviously 48 plus 74, that gives us 122. Straightforward, to the point, no beating around the bush, if you want to call it that way. And our marks, we get all of them, even though it is less steps than the previous approach. Okay? But it all needs your understanding. You have to know your stuff. Okay, let's look at this one. Okay, here we are asked to find the value of A, B, C. We are given these lines, A, B, and C, D. They are parallel, as you can see the arrows there, right? So look at the diagram. Okay, so I'm just going to give you 2 minutes to look at it and see what you can do. Then I see the person, I see you that you requested. I'll definitely accept you. I just want to give people a chance. Please don't use the comment section to write your answers. I want you guys to spend some time, look at the diagram, and then find the values of A, B, and C logically, approaching it with the right sort of like steps, step by step, move through the ranks, and get your values. Let me switch off the comment section so that I don't have people. No. You want to extend line AC to E. Okay, well, it's fine. We'll write E there, no problem.
How's it, sir?
I'm good, Demoho, and how are you doing?
I'm good, sir.
So are you ready to lead us along so that we can get A, B, and C?
Yeah, I am ready.
You are ready, okay.
Yeah.
Let's go.
So first we are going to say C equals to 65 degrees.
Just give me a sec. I want to switch off my beautiful comment section so that it can be you and you alone. Yes, you said? I'm listening.
C equals to 65 degrees.
C is equal to 65 degrees. I hope you heard what table for M is saying. C is equal to 65 degrees. What's the reason, table?
Alternate angles.
All right, I hear you.
AB is parallel to CD.
AB parallel to CD. So far, I'm hoping that everybody in the comment section, even though I cannot, obviously, I've closed the comment section. I hope we can appreciate what has happened here. Let's just look at it one more time so that we can see if this is correct. Just in case Tebucho is feeding us a bunch of beautiful, sweet lies. Right, so let's look at C. Let's look at 65. Their relationship, the C and the 65. There's a parallel line. There's a Z formation happening here. We have this angle and this angle. Hey, seems like our Z shape has come to the rescue. It's like Zoro has come to the rescue. Tebucho is 100% correct. C is definitely equal to 65. And the reason, alt angles. He even gave us the lines that are parallel. So I would say 1, we are happy here. 2, we are happy there. We update our diagram. Listening, I'm listening. So far, so good.
And then A equals to 45 degrees.
A is equal to 45 degrees. Okay, I'm listening. I'm not going to write anything down yet. I'm unsure about your answer. But you seem to
A
be
equals
sure.
to 45 degrees corresponding angles.
Okay, A is equal to 45 degrees corresponding angles. I'm listening.
AB parallel to CD.
All right, AB parallel to CD. This is basically what this man is saying here. I don't know if he's correct or not. I'm still shaky. I'm shaky myself, but let's check. A is equal to 45 degrees. He's saying, he's even supporting his notion by saying corresponding angles, and he's stating the lines that are parallel. Let's check the relationship. This here, F, I think it's F, the red F there in EFF, and then this line and this line, they are parallel. Bottom of this line, bottom of that line. So I would say that indeed, bottom of this line, there's the 45 degrees. Bottom of this line, there's the A. A is definitely equal to 45 degrees. It's the F shape. F shape means corresponding angles. then the lines that are parallel indeed are A, B, and C, D. So I would say Tebogo M is still leading us. He is not a false prophet. He is a true prophet so far. Let's check. A is 45. Let's update our diagram, 45 degrees. Now we need B.
And then for B, we are going to say B plus C plus 45 degrees equals to 180 degrees.
B plus C plus 45 degrees is equal to 180 degrees.
Then reason angles on a straight line or supplementary angles.
Angles on a straight line. So let's make sure that we stick to the one that basically helps us a lot. I think I think I had mentioned to you guys that the acceptable reason document is the document that we align our reasons towards. Yes, I am. Yeah, you see, my question is, what are you obsessed with? Me, I'm obsessed with this document. Look at this one. Look at this document. There at the top, it says the adjacent angles on a straight line are supplementary. The adjacent angles on a straight line are supplementary. So as a grade 10 learner, you are safe when you use angles on a STR line. That's what we use, guys. All right. Please, please, please. So any other reason, please don't go in the direction of any other reasons. There's no other variation. This is the one that we want to embrace. Angles on a straight line, that's short form. Okay. So if we stick to that one, then we'll be safe, you see. But if we are going to do a remix, grade 9, I can be honest with you, in grade 9 sometimes, in grade 8 and 9, when we teach in grade 8 and 9 as teachers, we tend to be a little bit open when it comes to the reasons, you know. But in grade 10, 11, and 12, there's no jokes, there's no fun and games there. You have to, we are very stringent in that we need to allow for there to be uniformity in the reasons that we use. So this document guides every learner in any part of the country. So please, let's align ourselves to that, right? So I hope that comment is received favorably. You know, it's meant to build and you know, strengthen. So that's why we say angles on a straight line for short. Okay. Yeah. And then we can go ahead. You can lead us. We can solve and get the answer so that we said 180 degrees. What's 65 plus 45? What do we get there?
B plus 110 equals to 180 degrees.
Thank you so much. Then
180 degrees minus 110 degrees. Then B equals to 70 degrees.
Awesome.
Type shit.
What is this? This guy. All right. So there we go. There we go. So I think, guys, we can just give this guy a sweet round of applause there in your little corners. He's done the things. It's spot on, 100%. No problem. Statement, reason, simplification, answer. That diagram, he has worked it out to completion. All right.
Type shit.
So thank you so much, Debohoy. Thank you. Really appreciate that. Thank you. So guys, I don't know if there's any other questions that relate, you know. So that's it. All right. I obviously, you know, it would be very important for each individual that's on this live to make sure that they revise, you know, as much of the grade 8 and the grade 9 concepts as possible. Okay. And I think to conclude this amazing live that we've just had, okay, I need to say that, you know, the more... Oh, you want to screenshot? Okay, let me just do that. I'll do that for you now. Let me just... And I'll expose you to each page of the statement. You think you really need a teacher for this? In their... You know, let me just, remove the comment section so that you can see it fully. So there it is, hey? Right? Something that I haven't gone into, all right? So if you look at the lines, we've covered everything that has to do with the lines, all right? Just in conclusion, I want to look at those last three rows underneath the lines, because I want to show you guys how to prove lines are parallel. How to prove lines are parallel. So we'll be checking that out. But yes, please do screenshot this. This is an important one because this document, it pretty much covers all the bases. And if you look at the lines, for all that we've done so far in the problems we were doing, we've looked at the first three rows. Angles on a straight line. Okay, obviously we didn't have to use the second row, adjacent angle supplementary, but that adjacent angle supplementary is something that you use whenever you are asked in a question, prove that a certain line is a straight line. So if you are given a certain line segment and they say prove that it is a straight line, you know, the minute you are able to see that, oh, two angles add up to 180 degrees, therefore AB is a straight line, the reason you would use is adjacent angles supplementary, which simply means those two angles next to each other, you were able to see that they add up to 180. And therefore, the line that is basically placed, that those angles are placed on, must be a straight line. That's why the theorem says if the adjacent angles are supplementary, the outer arms of these angles form a straight line. Okay. Then everything else, if you look at it, adjacent angles in a revolution add up to 360, you can see the two acceptable reasons. Angles around a point or angles in a rev. You see where I'm taking these things from. These are not things that I'm writing down as acceptable reasons because I want to. They are informed by an official document. Vertically opposite angles are equal. I'm sure you can see that. And then the three relationships for parallel lines, the angles that exist if lines are parallel. You can see that they always write the parallel lines together with the reason. Okay, so if they say alt angles, the parallel lines are there. They say corresponding angles, the parallel lines are there. They say co-interior angles, the parallel lines are there. That's how you complete that reason. Then the last three statements, the alt angles equal, the corresp angles equal, and lastly, the coint angles sub. These are the reasons we use whenever we are asked to prove that lines are parallel. There are questions sometimes you get asked in grade 10 where they say prove AB is parallel to CD. Okay. And in those situations, you either have to look for two angles that are in a Z shape, and you need to prove that those angles are equal, which would therefore mean that the lines are parallel if those two angles that are in a Z shape are equal. Or you have to prove that two corresponding angles are equal between two lines, okay, meaning the F shape, top, bottom, bottom. If top and top are equal, or if bottom are equal, then you can say the lines are parallel. Or last but not least, you have to prove that two angles in between two lines that are in a co-interior position are basically supplementary. If you can prove that those two angles add up to 180, then the two lines, right, in which those angles are in between are also parallel. So for our reason, we use one of three of these reasons depending on what we find. Okay, those are the last three statements the last three. If the alternate angles between two lines are equal, then the lines are parallel. Second one, if the corresponding angles between two lines are equal, then the lines are parallel. Third one, if the co-interior angles between two lines are supplementary, then the lines are parallel. Okay. Then underneath there, you see triangles. And guys, for triangles, you can see interior angles of a triangle are supplementary. You can see the reasons they use. Look at them. You see the reasons they use. There's three of them. One of three are acceptable. Use the one that is acceptable. Any one of these three. I usually say to my learners, choose one and then use it in grade 10, use it in grade 11, use it in grade 12. Don't change your reasons. Stick to one and use it forever. Whenever you have sum of angles in a triangle, you can see the interior angles of a triangle are supplementary. Take one and use it forever. Don't change it up. Then you see the second statement, exterior angle of a triangle is equal to the sum of the interior opposite angles. Okay. Then the third statement speaks to that thing where I said we do away with base angles of an isosceles triangle. We don't ever use that anymore. What we do use is angles opposite the equal sides in an isosceles triangle. So the angles opposite the equal sides in an isosceles triangle are equal. All right. And we use that reason. Angles op equal sides. Angles op equal sides. In the same vein, if you are given the angles in an isosceles triangle being equal, you can also say that the sides that are opposite those angles are also equal. So that's why we have that reason, sides opposite equal angles. If you use Pythagoras, you must give Pythagoras as a reason, guys. If ever you use Pythagoras, you have a right angle triangle, you are solving for a side, and you so happen to use Pythagoras, you must write the reason Pythagoras. AB squared is equal to AC squared plus AD squared. Reason Pythagoras. You must write that reason. Or you write theorem of Pythagoras. Okay. Then the converse of Pythagoras has everything to do with when we are proving that a triangle is actually a right angled triangle. The minute we prove that a triangle is a right angled triangle, we usually take the hypotenuse, we square it, we get its value. Then we take the sum of the square of the other two sides and we add those two, and then we compare the square of the hypotenuse with the sum of the square of the other two sides. If they are equal, we can then conclude that that triangle is a right angled triangle. And our reason is converse Pythagoras. The converse of the theorem of Pythagoras. One of those two. The last 1, 2, 3, 4 have to do with congruency of triangles. Guys, congruency, I hope we know about congruency. Triangles that are equal in side and angle. There are 4 cases of congruency. We have SSS, we have SAS, we have AAS, and then we have RHS. Okay, that speaks to congruency. Those are triangles that fit into each other. Triangles that look exactly the same are congruent triangles. And they are either congruent by the sides, all 3 sides being equal, all corresponding respective sides are equal, or it has to be 2 sides and 1 angle, but it's always the angle that's included, or 2 angles and 1 side, or it's a right angled, a hypotenuse, and a side. Then in grade 10, we learn a new thing, which we refer to as the midpoint theorem, which I will do with you guys as we go along. The midpoint theorem is new in grade 10. All right. For those that are doing caps, midpoint theorem is new, and there's the reason for using the midpoint theorem. So this is document, very important, guys, very, very important. All right. So I hope you screenshotted it and you have it, and yeah, it makes sense. Okay, which is very important. that it makes sense. Okay, and then let me just move right along. I just want to show you the you might as well screenshot this document. I'm going to also show you the document as well that do quadrilaterals as well. So please don't mind the theorem statements that are above quadrilaterals. See, where quadrilaterals start is what we are focusing on as grade 10s. What is above does not have anything to do with the grade 10 syllabus. It has to do with the grade 11 syllabus. So don't mind the rows that are above quadrilaterals. Look at the rows below quadrilaterals. So everything there is something that we are going to be using as acceptable reasons in grade 10. So you guys need to, I'm sure in grade 9, when you did quadrilaterals, you knew that the interior angles of a quadrilateral, they add up to 360. You knew that. That's something you learned last year. So for that, we usually write sum of angles in a quad. Sum of angles in quad. That's the acceptable reason. Last year, you may have said something about a parallelogram and the fact that the opposite sides of a parallelogram are equal. There is the acceptable reason. Opposite sides. And then they use the symbol for parallel lines and they put an M next to it. Okay. So basically all of these guys, everything below that is also important. Okay, I'm not going to go through each one because when I do quadrilaterals, I'm going to come back to this document. I just needed you guys to have it so that you know it. Okay. All right. I think with that said, we can officially call this a day. Okay. Okay, guys, thank you so much again. It was, this was a good, fruitful session. Please, no, you guys are stars. You guys are stars. You guys are the ones that are amazing. So thank you so much. Thank you guys. All right. Say use different colors for angles. Guax 75. Yeah, sure, you can do that. Tell us the website for the PDF. You can just you can actually just Google it. Okay, just type in. You see at the right column there. You can just say Euclidean Geometry acceptable reasons. They have that as a PDF document. It's always available. You can actually use it. Yeah, just Google it. PDF document for acceptable reasons for geometry. Yeah, it's there. Okay, guys, I need to